Okay, hello and welcome to my talk on flexible data access with graph APIs. I'm now working at Netflix, so I'm no longer as involved in the Plone community as I used to be, but I thought it would be helpful to, especially with the discussions about how the REST API and the like headless CMS and so forth, what's going on in like other communities about how we solve the kind of problems that we get when we're trying to build a separated UI from the back end. So this is the front page of Netflix from last night, and you'll see on that there's quite a lot of information that goes into rendering that page, and so you've got the list of movies here, which scrolls down to many, many more of those lists. And so the question is, how do we return the data to the UI, including the information on all the things that we want to render? So, and our digital experience now spans web, mobile, and at Netflix, our TV app is actually the most important way of watching it. And all of these devices use different technologies, so you need to be able to access your data API from multiple stacks and be able to render that in the right way for your system. And each will choose a different set of data, because if you're building an application for an iPhone or an Android device, it's going to be quite a different interface to the kind of interface you would build for either a website or a television which is sitting 10 feet away. So the obvious thing you think is REST, but how do we actually build a REST endpoint that works for all of these different use cases? I mean, what you can do is build a custom endpoint which is specified exactly for your for the screen that you're building, but then you're quite tightly coupled between the UI code that runs in the browser or the mobile phone and the server code, and it's like frustrating to switch between the two all the time. And REST really has no, and you can't simply make multiple REST requests, because those multiple round trips will kill you. I mean, it's just going to make it a very slow experience. So we need to use a graph API, and I'm coming up with this term. It's now being used not as a computer science term, but there is a new generation of systems being built which are trying to solve this problem in a practical way. And the key thing about them is that they allow us to query and return composite results. And this means that you can configure what you need next to your view code. And so, and that's really an important thing for developer productivity, because you want everything for rendering that view together. You don't want to be switching from the JavaScript UI into a Python view module to just choose that you need one extra attribute on your results because you've tweaked the design. Now, I'm going to talk about a few different technologies. The first of which is Falco, which I work on at Netflix. But my point is not to say like one is better than the other. I don't know what is the most appropriate one for Plone. And really, when it comes down to it, all of these systems have more similarities than they do differences. What I hope you get out of this talk is sort of a broader understanding about what might be possible and what the implications might be for building that. For building the ability to access Plone through these types of APIs. Okay, so every page you view on Netflix goes through Falco. Falco is an open source project, although it's very much a Netflix project which is open source rather than more than a true open source, an open source community project at this point. And so the key, I guess, in all of these systems, like the core problem is how do you express the part of the graph, the part of the result, which properties you want in a request. And in Falco, we specify lists of paths, each one's a key, and we also have a sort of a shortcut syntax, which is slightly easier to, involves typing fewer characters to get the same result. I guess the overall, or the core idea of Falco is that really we're just trying to choose which part of the graph we want, and everything is just essentially a big JSON document. And so, as well as like each value has a particular path, but we normally want to request a number of them, so we can combine them together in this shorthand path set syntax. So what does it look like from the client side to fetch data with Falco? Well, you connect to your Falco endpoint on the server, and the model is really sort of equivalent to the ZODB connection, if you like. It's the root of everything, and you say get, and I'm asking for a very small amount of data here, which is sort of like one of the name and rating of just one video. And then because it's JavaScript, everything is asynchronous, and once it returns, you then get called back with the data that you've requested, and importantly, in the structure that you have requested. So you see here that I've asked for the first genre, the first row of the genre list, and the first title of that list, and name and rating from there. So I get back genre list 0, titles 0, rating and name. And it looks a bit funny having integers as keys to an object here rather than an array. But there's a reason we do that, and that's because if we return the whole array, it would contain far too much. It could potentially contain far too much data to show. So we want to be able to specify only a slice of that array to be returned. And the magic of JavaScript, you access it with the same syntax, and it still works. But what goes over the wire? So when I made that request in the browser, I see an XML HTTP request head across, which asks for that path. And what I get back here is not quite the same thing as I saw in the result earlier. I get back a JSON graph response, which returns, which includes references to other values in the graph. Why do we do that? Well, really, when it comes to it, our content is not necessarily a tree. Although when we want to render it, we want to render it as it's most convenient to have the form in a tree. We don't want to return the same data multiple times in the response, as that would be inefficient, and would also prevent us from being able to cache the data that's returned locally. So what's a JSON graph? I mean, the idea is that it's essentially just JSON, but it's extended slightly. So as well as the primitive value types, we add references, which just point to the path in the graph where the result is. And we also support what we call an atom if we want to return a more complex result in a single value, because it's just JSON, so we don't have the luxury of creating our own types. And it also allows us to add metadata to the response so that we can control the client caching. And finally, we're also able to return an error at a point in the graph if we want to have an error which is specific to that path. So maybe you're not logged in, and so certain parts of the graph are now off limits to you, and they're unauthorized, but you're still able to see various other parts. And the operations we can do on the JSON graph are really analogous to HTTP's get, put, and post. We can retrieve a value, we can set a simple value, which we assume. For instance, if you're setting your rating, you click a button on the number of stars that you want to give a particular show you've seen. We'll assume that that's always going to work, or it's very unlikely to work, to not work, and so we can, as it's only touching that single value, we can update our local client cache and then make the request and not make the user wait for the network request to complete before updating the user interface. And finally, we have call, which gives us much more flexibility and importantly allows us to combine to do operations which might affect multiple values, and we want them to happen in a transactional manner. Actually, at Netflix, almost everything we do is a call, compared to a set. And from that call, you can return updated values or invalidate parts of the client's cache. So let's just look over the sort of architecture of that. We have on the client, we render the view by asking the model for a set of paths. The model will first look in its cache to see whether it can render them without having to make a network request. If they're not there, it will then request the bits that are missing from the server, and at the server you will write you will have a router which will satisfy those results and return the data. The way that the Falco router is constructed is really as a data integration point. It's not the source of truth. It forwards them on from other things, and its job is more to aggregate all these various services together under a single logical graph. It will look something like this. You specify the path that you want to match, and then you'll be able to return the values that come out of that. I mean, because you're only being, this is an appropriate way to build a router when you're doing data integration. But if you were building this a Falco JSON graph endpoint that talks to Plone, then, well, we have a graph in the ZODB and traversal anyway, so we'd probably use traversal rather than route matching for those to satisfy the results. And let's go back here a moment again and just think there are several commonalities here with ZODB. And in a way, I don't think it's unfair to think of this system, and like some of the other systems too, as very analogous to an object database. We have a client cache, much as ZODB does. We even have references between objects in the same way. Now, there are some differences too, in that really the sort of atomic unit in JSON graph is the property rather than the object. And it's an eventually consistent view of your data rather than a consistent transactional view of your data. But for user interfaces, that's probably okay, and I suspect it would be far too slow to try and have synchronous access to a graph which is potentially shared between multiple users. And one of the other things that's interesting is that when we make our request here, the server is aware of the structure of your data as well. So when we ask for this path, we actually we end up requesting the whole path from the server, the whole missing path from the server. And that reduces the number of round trips that happen. I mean, there is now in ZODB, we learned from Jim's talk the other day, the ability to preload objects, but that's only specific objects, and you can't make it like walk the graph for you. But in ZODB, that's not really much of a problem because the latency to fetch a new object is much lower. Okay, so I'm going to try and sort of show how a similar application would be built in GraphQL, or how GraphQL works. And GraphQL is another Graph API which has recently become is seeing quite a lot of adoption. It comes from Facebook. It's just been adopted by GitHub for their API as well, and it has a different take on things. So, whereas Falco thinks of the server as a sort of a big JSON document, in GraphQL you have types, and when you build your router, you end up it ends up looking much more like an ORM, and you build the endpoints there. You specify a root object, which has which is the entry point into your graph, and this then and then you can traverse the way that you query that is through sort of the arguments that you supply. And so let's look at a similar query here to the Falco version we had earlier. You can see we're able to supply arguments to the lists, or the functions here to return the subset of results that we want. In Falco, those query parameters end up living in the path of your graph. So much in the same way that that if you're using routes from using route matching in Pyramid, you would pull out the query parameters from the traversed path. So if you are asking for a search results, you would actually include the search query in the path that you're requesting. Now the GraphQL language has been has multiple implementations in different languages, and I think probably the fact that it's typed makes it an easier fit for systems where you really want to where you're trying to sort of use it with a statically typed language. So on Android, working with JSON in Java is not a terribly pleasant experience, and it would be much nicer to have everything converted into an object that is sort of more native to that that language. And so the fact that we have types here, types in GraphQL, has some advantages. It also makes you sort of model your data in a slightly different way, but I think you can probably achieve the same end result. Now, one of the things that GraphQL, well, is not part of like the core GraphQL standard, but is available is this sort of client cache and model. In the GraphQL world, that's called Relay, and Facebook's Relay is quite tightly integrated with React, but I've seen in the last couple of weeks there has been another company that's released an equivalent system for which is more general. And so finally, I'm going to talk a bit about JSONLD, and JSONLD is although it's related to the semantic web RDF world, it was built very much not as a sort of semantic web take on everything, but as it was built as a means of sort of like building better web APIs. And so I like to think of it as a much more practical approach than RDF and that world where everything is a triple, which is wonderful in theory, but not necessarily terribly performant in reality. And so with GraphQL, with JSONLD, you essentially are able to annotate semantic information onto. Along with your response, you sort of give it information about the semantic meaning of your data, and this is really useful when you're trying to build mashups across multiple different data sources, because if you agree on a vocabulary of types or of properties, you can then link across, and the links or the references in JSONLD are simply URIs, and so it's a relative URI here, and as well as just the single object, you're able to expand a reference you're able to embed the data of a reference in that result as well. And so we end up here with a very similar structure to the results we saw from GraphQL and Falco of which hopefully matches the kind of structure that you're trying to render. Now, although JSONLD has seen a lot of adoption recently, and one of the more common uses for it now is you can embed a little snippet of JSONLD in an HTML email, and if you use the correct schema, you'll be able to. Gmail might render you an action button. So if you get an email from GitHub now, you quite often get a little snippet in there as well. And so I think JSONLD has seen is seeing quite significant uptake for publishing data, and it seems to have become the sort of common replacement for what we used to try and do with, metadata properties in HTML and the various inline semantic properties that you'd have with HTML. But there's no sort of, the standard doesn't really cover a way or a specific way of querying data. and specifying which parts you want. There is a proposed standard for JSONLD framing, which is really the same kind of concept as like specifying the paths that you want to be there, or the structure of your document. But it's fairly complex, and it's not at all clear whether it's a good fit, whether at least JSONLD framing is a good is a very usable way of specifying which data you want in a result set. And as well as the embedded view of the data, you can also have a flattened view of the data, which will remove duplicates and has everything as a single flat list, which, when you have quite a lot of common data, when you have the same objects appearing multiple times in a response, can save you quite a lot of space or size in the response. So, any questions? Just before that, I'll sort of emphasize again, I don't want to sort of push Plone in a particular direction, but I feel confident that these types of APIs are something which we will absolutely need for building a for building a sort of rich UI, and also it sort of opens up Plone to like be a more flexible backend for building mobile apps as well, if we can find some way of doing this. And I suspect that like none of these technologies are terribly mature yet. So like think about how it will. I think about how you build the infrastructure to serve responses like of this sort, rather than this particular being too tied to any particular technology. Perhaps like think about that maybe we want to support multiple different serializations of the data in Plone, depending on which client library people are using. Okay, sorry, I'll open it up to you. Yeah.
A lot like what we were looking at this morning in a keynote, that between different languages there's a lot of similarity. These look to be just like kind of your preferences to what you want to see, or what looks most. I guess you would look at the performance of a thing, and you would look at the internet and see what is better. But in the end, the most important thing for me would be how easy does it look for me to access what I'm getting back, and how much kind of sense this, how much am I going to build myself into a corner with this because something's linked in a weird way. But apart from the structure of what I'm getting back, for very simple cases, obviously it's exactly the same as just querying, because you're not looking at anything that's linked from all over, and you're not looking at combining duplicates, and you're able to sort of, like you say, do more tightly bound things from one side. But it doesn't sound like sounds like something you could do. It doesn't sound like something that would be change really anything that's happening in Plone and Zope. More that Plone and Zope would have to modify their your schemas on that side would have to be built with this in mind. Not that there would be a change in the technology.
Possibly. I mean, I think I think you can absolutely build this. You can view this as like a layer on top, sort of like that is built atop Plone REST API. The only thing that might not be the only thing that you might want to add into REST API to like be able to build this on top is the ability to specify in a particular REST request which properties you want, because maybe you can if you're only asking for the title, then and you don't need to render the body text, then that's going to be a faster response. So like just to avoid doing work which you would then throw away. But you could absolutely build like have a system that sits in front and then talks to Plone through a REST API and does the like the integration that way. Yes. So does that?
Because it kind of sounds to me like not doing it this way is an oversight. You when you're not querying for something and then looking at your result and querying for something else, which is kind of the way that you start to think about it. When you get one level above that, this has to be the way it's done. You have to be able to say, give me everything I want because I want to go off and do something with it. So it's I'm kind of at a loss for a place to bite, but I can feel that it's something that I need.
Yeah, I think once you start building real, like completely separate UIs, you need something that gives you this functionality of multiple, like data for multiple like objects, resources in that same request.
Sorry, a related question. I don't want to get in anyone else's way.
That's okay.
That with this specific example, titles, genres, like you say, you have to agree on the vocabulary that you're using, and so maybe a first step to understanding it as a complete querying technology is to say how would you discover the schema in use? How would you say, okay, well, as from the you want, I mean, you can't be completely unbound. You need to know the schema, but there should be a way to say I'm working on this now, and I mean right now in my schemas I say go look at the source, there they are, but there should be a way to say what's available to you here.
So that's definitely there in GraphQL, and that you have to have a schema on the client as well. Falco doesn't require a schema on the client, although I can see it being very useful from a documentation perspective. And I guess in JSON schema, you're doing with JSONLD, with the context can provide a list of properties. But yeah, I think in Plone we already have the dexterity schemas of our objects, so it's I don't think we'd want to I think we'd want to generate any schema that we use client side from that. Okay, so anyone else? Okay. Oh yeah, Miko.
Yeah. So let's say that I have a front end in React and a back end in Python. So is there any because I saw in your Falcon examples you were using Node at the server side. So is there anything similar I would use on the Python, or do I need to start from scratch?
So I know that there is a GraphQL package for Python. I've not used it, so I don't have any idea how useful it is. Falco, we don't have a Python library, but the protocol itself is very simple. So for Plone, it would be quite easy to sort of like build it. I think to try, because we could use traversal and JSONLD, there isn't the same sort of like client libraries around JSON. Well, there are client libraries around JSONLD, but they I probably wouldn't recommend. I suspect it would be slower than using GraphQL or Falco, which are, or at least if you are consuming the JSONLD as semantic web stuff rather than a simple JSON document. So the answer is maybe not really, but it may not be as hard as you think, and perhaps try the Python GraphQL thing. Okay. So up the feedback side. And if anyone else has questions, I'm happy to ask them now, or you can come up to me afterwards and talk about it. I'm more than happy to sort of talk over it, or any of these things. I'm not an expert on GraphQL. I've really not built very much with it, so I may not be able to help you, but yeah, they're all interesting. Thank you.